Okay, so in the first part of this lesson, we learned about direct variation. And we learned direct variation is of the form y equals kx. Y and x are what you look for, and k is your constant proportionality. Now, that was when both things increased or both things decreased. When one increases as the other decreases, that is called inverse proportions. And that's where you have y equals k over x. That's really the only difference in what we're doing. Okay? So, example 3 says y varies inversely with x. So that's your key to know that y is equal to k over x. And then it says if y equals 40 when x equals 16, find x when y equals negative 5. So just like in the last example, substitute in what you know and solve. So multiply both sides by 16. Okay, what are we going to get? These cancel, and I can't do math in my head right now. So 0, so 4, so 640. So k will equal 640. Then it says find x and y is negative 5. So we're going to say now that negative 5 is equal to 640 over x, which means negative 5x equals 640. Divide both sides by negative 5, and what do we get? So we get that x will equal negative 128. Okay, don't forget that negative sign. Let me rewrite it. So negative 128. Okay. Example 4. The note played by each pipe in a pipe organ is determined by the frequency of vibration of the air in the pipe. The fundamental frequency F of an organ pipe is inversely proportional to the length L. Now, I didn't mention this in the last video, but it's very important that you write the letters in the order you read them. That's going to tell you what goes on one side of the equal sign. That's going to tell you what's connected to the constant proportionality. So it says find the fundamental frequency of a 1.6 foot pipe. So find F when we have this over here. If we know that 64 vibrations come from an 8-foot pipe. Okay, so 64 equals k over 8. We don't have enough information to solve this F and k one yet. Multiply both sides by 8, and what do we get? That's what, 512? So we know k is equal to 512. We can now take this value and we can substitute it in for k and solve for what we are looking for. So we know, or we are looking for the frequency. So we're looking for F when the length is 1.6. So all we have to do for this one is do 512 divided by 1.6. What is 512 divided by 1.6? I'm too lazy. And you will get that F is equal to about 316.05. Do we have a label? Vibrations, I guess.